By definition, an acid is a compound which donates an H plus to another compound. On the other hand, a base is a compound which accepts a proton. Once the acid has donated its proton to the base becomes the acid, and the acid becomes the base. So determining whether a substance is an acid or a base simply requires us to determine whether it has an H plus to donate or whether it can accept an H plus. Note that any of the anions in this table can accept an H plus and therefore act as a base. So acetate can accept an H plus to become the neutral acetic acid. So each anion in this table can act as a base, add a proton, and become an acid. So every anion has an acid form that is created by adding an H plus to the anion. In addition, monoatomic anions, like fluorine, can also add an H plus to become an acid. So HF is the acid form of F minus, which is a base. The other halogens can also form acids, but it's important to note that they are exceptions to the base rule. So HCl plus H plus does in fact form hydrochloric acid, as does Br minus and I minus, but their anions do not act as bases. There are also several exceptions to the rule in the table of polyatomic ions. So chlorate, perchlorate, chromate, nitrate, and hydrogen sulfate or bisulfate are also not bases, although adding protons does make them an acid. Note that any ionic compound which produces the anion in solution will be a base. So for instance, if I make an ionic compound between sodium and acetate, and I put that in water, I know that it's going to break up into its constituent ions. So I'm going to get sodium plus in water, and I'm going to get CH3COO minus in water, and that CH3COO minus is going to act as a base. Finally, there are two other curious compounds in this table. The first is ammonium, because it is positively charged and it's the only cation in this list of polyatomic ions. So ammonium already has an extra proton, and it is an acid because it can donate that proton to ammonia, which is a base. The second curious anion in this table is hydroxide. Notice that if we add a proton to hydroxide, we will form water. So the hydroxide has accepted a proton to make water, so water is acting as an acid in this case. However, interestingly enough, water can accept another proton from something and form H3O+. So notice that water can act as an acid or as a base. And a compound that can act as both acids and bases is called amphoteric.